All right, and welcome to Absolute Value Transformations, Level 1. Now, the first thing we're going to do in problem 1, it says describe and graph the transformation of f of x equals the absolute value of x to g of x equals negative 2 f of x. Now, notice that here, all we see is the absolute value of x. That's actually what we call our parent function. And you're going to graph the parent function in every single one of these. So what does the parent function look like? It has a vertex at 0, 0, or aka the origin. And if you go to the right one and up one, there will be a point. And if you go to the left one and up one, there will be a point. And this really continues forever and ever. To the right one, up one, we have another point. To the right one, up one, we have another point. And it will look something just like that. Okay, well, let's go ahead and graph g of x. Now at g of x, notice something. We have this 2 in front of f of x. So what are we really saying? We're saying, okay, when I go to write g of x, I'm going to put a 2 in front of everything that is f of x. So if f of x was the absolute value of x, which we can see right here, since this negative 2 is to the left of the f of x, well, I'm going to have to put it to the left of my absolute value of 2. Okay, and so this is actually what we call our a term. When we talk about, let me go ahead and write this out. When we talk about f of x equals absolute value, x minus h, close absolute value, plus k, well, it's this a value that's always in front of our absolute value symbols. And when a is greater than 1, we have what's known as a vertical stretch. And when when we say 0 is less than a is less than 1, or aka a is in between 0 and 1, we have what's called a vertical compression. Okay? And so here, since this, and you want to break this out into two parts. Also, when we have a negative a, we say that it is reflected down. Okay, so we know that we have a negative 2. Let me switch back to blue. We have a negative 2, so we know that our graph is going to have to go down. And this 2 can be written as 2 over 1. This means that we're going to go down 1, 2, and to the right 1, and down 1, 2, and to the right 1 again. And then on our left side, we just mirror this. We go down 2 and to the left 1, and down 2 and to the left 1 more. And even though you can't really see it, this graph has actually gotten skinnier, or it's gotten narrower. So what do we say? We say that we have a vertical stretch, and we are, let me switch colors, and we are reflected down. So we have a vertical stretch, and we are reflected down. By the way, guys, remember, vertical stretch just means that it's getting narrower or skinnier. All right, let's go on to example number 2. Okay, here we have example number 2. And notice that I left all my notes to the right. So we want to describe and graph the transformation of f of x equals the absolute value of x. And y'all can just get in the habit of going ahead and just drawing it as such, to g of x, which equals 1/3 of f of x. Notice, because the 1/3 is our a term, it's in front of the f of x, we'll write g of x as such. G of x is equal to 1/3 whatever f of x is, which is the absolute value of x. Now notice this is a positive number, so we say that it is definitely going to open up. It's not reflected, we should say. And because 1/3, we can say this, we can say that 1/3 is less than 1. Well, we know that we have a vertical compression. Now, vertical compression really means that the graph has actually gotten wider. So let's see why that is. Let's see here. There's nothing being added over here. There's nothing being done to the x itself. So let's go ahead and use a blue for g of x. We'll say we still start at the origin, and this 1 tells us that we're going to go up 1, and this 3 tells us we're going to the right 1, 2, 3. And there's our next point. And we could go up 1 and to the right 1, 2, 3 again. We'd be right there. And notice that's half the graph. But absolute values reflect over themselves, And so we could say that our other side would look equally as wide. So notice that whenever we have a vertical compression, our graph is actually getting wider. And remember, it opened up because the 1/3 was positive rather than negative. Okay, I hope that these help, and I'll catch y'all in our next level.